Hello and welcome again to the online lecture series of St. Andrews Institute of Technology and Management. And my name is Imran Siraj and I am taking subject called Standard Material. So in today's lecture, we will be discussing about beams and supports. Standard material is, as I earlier said, that it is the subject in which in which we study the different behavior the different behavior of the materials. How do they behave? What are their reactions, and how do they are analyzed? So today we will be discussing beams and their supports. So we can see here beams. You can see beams are basically horizontal components or horizontal elements of an infrastructure that are used to transfer or uniformly distribute the loads. So beam is a device or an element of the infrastructure that is used to uniformly transfer or transform the loads applied on it. So beams are these elements that are used to transfer or transform loads. These are horizontal components of the infrastructure, and beams are basically five types are there. So first are cantilever beam. Cantilever beam are we can see the cantilever beams are that are fixed at the one end, and on the other end they are free and they are hanging. So at the end, another end, there is no support. You can see here at B point, there is no support, only A point has been clamped from both the sides, from the top and bottom side. So this is known as cantilever beam. Cantilever beam, a beam which is fixed at one end and free at other end. This is called cantilever beam. There is no deflection or rotation at fixed ends. So fixed ends do not undergo any changes, whereas only free end, only free end is undergoes the changes, deflections. So cantilever beam is there. So cantilever beam is that is fixed from one end and free at another end. So all the changes are occur at the end B and no change occur at end A. Second is simple supported beam. Simple supported beam is supported from both the sides. Vertical support from both the sides are there, but at one end it is roller support and other end it is knife edge support. Roller edge support is a support that is based on rollers, and knife edge support is pinpoint support, and this pinpoint support gets vertical reaction from the support. So the reaction of the support is pinpointed and vertical upwards, whereas in case of roller support, the reaction is inclined, and that is inclined to the beam. So rollers are given there in case the beam expands. So these rollers will help the beam to move out. So at one end there is knife edge support or pinpointed support. Another end there are rollers, and these rollers are basically used for two types. One are they're supporting an inclined direction, and other is that the support will that the end A can expand in this direction. So rollers are the support that are basically that can expand, that can let the beam expand. So as usually we have seen that bridges and flyovers expand in the heat in the summer vacation. So one end is kept at the knife edge, another end is allowed to expand so that the beam does not distort and beam does not fail. So this roller support is given for freedom for moving a direction into negative x direction. So this is called simple supported beam. Then third type is fixed beam. Fixed beam, we can see both the edges are fixed from both the side. That means they are both having they are both having a beam whose both ends are fixed are known as fixed beam. So they are not allowed to expand in either direction. And if they expand, this expansion will be upward direction or lower direction. And this way, this will not remain horizontal. When it expands, it will not be in horizontal condition. Whereas in the case of simple supported beam, the beam was always in horizontal direction and it was allowed to expand inward direction. But in the fixed beam, the beams are not allowed to expand in horizontal direction, and this way they can only either go upward or can go downward. So these are fixed beams. Fourth is overhanging beam. Overhanging beams are the beams that are basically extended beyond the reach, beyond the support. So we can see there is one pinpoint support or edge support. This one is B, and whereas A is roller support, and both the ends are overhanging overhanging and they are extended outwards from the support. There can be either in one direction or both the directions. So if it is it is extended, it is overhanging in one direction also, it would be known as overhanging beams. So it could be either one way or two way, but the overhanging beams are that are basically projected, that are extended outwards of the support, and at the end they are not supported. So the overhanging beams are there, they are supported, slide inwards the support, slide inwards the slide outwards the support. Okay, so last ones are continuous beam, and continuous beams are the beams that have many, that are supported continuously, many supported continuously, like we uh, known as railway tracks. Railway tracks are continuous beams, and uh, they are continuous. They are running continuous for finite elements, finite number of pieces. So they are known as continuous beams. So a beam which more than two supports is continuous beam. Such a beam may or may not have an overhang. Okay, so another thing is that it may or it may not overhang, but the basic requirement is that it must have more than two supports. If they are having more than two supports, they are known as continuous beams. So these are five types of beams. So we have studied, one is cantilever beam, then cantilever beam, then overhanging, then cantilever beam, then simple supported, fixed, overhanging, and continuous beams. These are five types of beams. Now we'll be talking about types of loads. What types of loads are there? So because when we'll be going for this way, we'll be going to study shear force and bending moment diagram. So shear force and bending moment diagram, before standing shear force and bending moment diagrams, we must be clearly able to understand types of loads also. So types of loads are there. So we can see loads are there. One are concentrated load, point load, that exactly act at a particular point, like we are standing or sitting. So that means this way we are exerting, our weight is acting vertical downwards at a particular point, or we are sitting, then also our weight is acting vertical downwards at some point. So this is called concentrated load or point load. Point load that are considered to be acting at a single point. Then uniformly distributed load. Uniformly distributed load are the loads that are equally distributed or uniformly distributed over a span, over a length. So the whole weight, the idea is that whole, rather than acting on a single point, the weight is distributed uniformly so that it is transferred safely to the ground. So uniformly distributed loads are basically the loads that are equally distributed, uniformly distributed. So we can see here point load is W, downwards, acting downwards. A and B are the supports, roller support and midpoint support, and point C is having a point load, vertical, acting vertical downwards. And in figure B or 25.7, we can see uniformly distributed load, and distributed load is represented by uh, marking of spring type. So this is uniformly distributed load, and this is given in newtons per meter, whereas the point load is given in newtons, absolute figures, maybe newtons, maybe kilogram force, but the weight is always given absolute dimensions. Weight is absolute, given in absolute weight, that is kilogram force or newton force. But uniformly distributed load is told how much weight is acting per unit of length. So this way we can see it is given W Newton per meter. So when W Newton per meter is acting, that means we have to get, in order to get the complete load, we have to multiply the uniform distributed load with the length of beam. So if it is W Newton per meter and it is 7 meter, so this way it will be 7W newtons. 7W newtons. Whole weight will be 7W newtons. If the span of the beam is 7, then this has to be multiplied with the load per unit load per unit length. Okay, so this is called uniformly distributed load, and this way Newton per meter. Okay. But one question, another point is there, that when this uniformly distributed load is converted into concentrated load, because no calculation can be made by this uniformly distributed load. In all the calculations, we have to convert the uniformly distributed load into the point load. And this conversion is very small, very simple. When the uniformly distributed load is given as Newton per meter, this much force divided by per unit length, then this is multiplied by the span of the length. It may be 7. If it is 7 meter, then 7W newtons. Okay, and one more thing, that the point on which this uniformly distributed load being converted into point load, at which point it will be acting, this will be acting exactly in the center of the beam A and B, support of beam A and B. So if this uniformly distributed load is converted into simple supported beam, this uniformly distributed load is converted into point load, this has to be acting at the exactly at the middle of the beam, and we can find the potential or value of this point load. So this point load is a product of span and unit per load. This was uniformly distributed load. It is evenly distributed to the entire length of the beam. And another one, the third one, is uniformly varying load. Uniformly varying load, we can see this is load that starts varying from one end and ends to the another end. Starts varying this way, we can see figure 25.8. At this point at A it is 0, and it starts increasing, and at point B it is maximum. At point B it is maximum. So this is known as uniformly varying load, and this is uniformly distributed, uniformly varying, like the, if you take any sections, any one section, if you divide the whole beam into 8 parts, or divide the whole beam into 16 parts, you will be seeing that the load, the pattern of load distribution is same. It's not like that in the first section is too much, again, or is too little, then in the second section it's too high, or like that. You will not find any irregularity in the distribution pattern of this load. So either you take any section, if you divide the whole beam into 16 parts or 28 parts or any in number of parts, you will find the pattern of loading the beam is uniform in all the sections. So this is known as uniformly varying load. Now this is a combination of uniformly varying load plus uniformly distributed load. So a combination of above loadings. So in fourth, we will see a combination of uniformly distributed load plus uniformly varying load. We can see at point A it is already loaded. So from point A to point B, a uniform load, uniformly distributed load is acting, as well as we can see the magnitude above the dotted line is uniformly varying load. So it's a combination of uniformly varying load plus uniformly distributed load. So we can add similar like this. So as we have seen earlier, it can be found by combining these two, a combination of uniformly distributed load and uniformly varying load. So we'll be talking about a few examples. We can see here that this is a beam. This is pivoted at one side, and this is roller support, and F is acting vertical downwards. So F is 100 Newton. So 100 Newton is acting vertical downwards. The roller support has a vertical upward reaction, RB, and a roller support is there. So uh, RA is like this. We can see A, B, C. B is the support. C is the vertical loading, vertical downwards loading, point loading. A is a pivot or fulcrum about which the point is to be taken. So if we have to solve these problems, we will take simply moment. We can take moment about any point, because we have earlier studied that two conditions are necessary in equilibrium condition. First is sigma fx must be equal to 0, sigma fy must be equal to 0, and sigma m about must be equal to 0. That means all the vertical components, if they are added up, their sum must be 0. Similarly, all the horizontal forces, if added up, must be equal to 0. And if moment is taken about any point, the whole moment, the equation of moment must be 0. So that all the upwards forces nullify downwards forces, and horizontal leftward forces nullify rightward forces. And similarly, moment about any point is 0 if the beam is in equilibrium condition. So another question is there. We can see this is pivot about which, a fulcrum about which this beam can rotate. So we are having two reactions. Actually, I told in case of pivot or roller, we have in case of pivot or fulcrum, we have an inclined reaction. So this acts like this. So this is combination of vertical and horizontal reaction. So we can see there are different types of torques acting. This one is pin roller support, pinpoint support. So the reaction is vertical upwards, and again we can see uh, momentum of moment of 20 kilonewton is acting, 10 kilonewton is acting, and 20 kilonewton is acting. So very good example. So you can check yourself. Here is example. So this way you have to find yourself solution, and if not able to solve, you may get in touch me and will call me. These are very simple problems that I have given. So this is just to understand the basic idea of types of beams and their loading. So this you will again see we have different types of loadings, different types of uh, under the different conditions of loading. So these are supports. So you can solve all these problems. These are three problems, very easy problems, so that you get the basic idea of the support. Okay, so in our next lecture, we would be talking about bending moment and shear force diagram. Okay, so bye for now.